A function can also be considered to be either even or odd, or maybe neither. But an even function occurs when opposite inputs into the function give the same outputs. And notice our notation here, f of negative x. So when I input a negative x value, I get the same answer as f of positive x. So a good example of this is the absolute value function. I'm calling it g. If I plug in opposite inputs, so I'm just going to pick two random numbers that are opposites. We'll say 3 and negative 3. When we plug 3 in for x, the absolute value of 3 is 3, because it's 3 places away from 0 on the number line. When I plug negative 3 in for x, negative 3 is how far away from 0? 3 places. So notice opposite inputs, 3 and negative 3, gave me the same outputs, positive 3's. And on a graph, even functions are all symmetrical over the y-axis. Or in other words, if your y-axis is acting as a line of symmetry, the function is even. Now, we'll go and compare and contrast with odd functions. In an odd function, opposite inputs give opposite outputs. And our notation there, just see if that kind of makes sense. I input a negative x, and my result is I get a negative y, or a negative f of x. A good example of an odd function is a cubic. H of x equals x cubed. I'll do the same thing. I'll pick 3 and negative 3 as my two inputs. So when I do 3 to the third power, 3 times 3 times 3, I get 27. And when I do negative 3 to the third power, negative 3 times negative 3 times negative 3, I get negative 27. Opposite inputs, 3 and negative 3, gave me opposite outputs, 27 and negative 27. And on a graph, an odd function is symmetrical over the origin, or through the origin. And I think an easy way to decide whether something is symmetrical through the origin is if you rotate 180 degrees and your graph looks identical to what it did right side up, then it is symmetrical through the origin, which means it is an odd function. If I want to decide whether the function negative x squared plus 3 is even, odd, or neither, I've got two possibilities. I can either plug in two opposite inputs. For example, we'll do 4 and negative 4. So when I do 4 squared, I get 16. Multiply it by negative 1 would be negative 16, plus 3 would make negative 13. Now for f of negative 4, when I do negative 4 squared plus 3, negative 4 squared makes 16. Multiply by negative 1 would make negative 16, plus 3 is negative 13. So I got the same answer for two opposite inputs. So that means this function is even. And I could also check that on my graph. If I graph this function, notice the parabola is symmetrical about the y-axis. The y-axis is a line of symmetry, so that would tell me the function is even as well.